Hi, this lesson is about log laws. I'm going to introduce 5 laws to you. We're not going to prove them, but we're going to verify them by recognizing number patterns. There's no particular order or number equivalence to which law is which pattern or rule, so you don't need to worry about that, but you need to make sure you're familiar with these 5 laws. And the first one is the inverse law, which you're already familiar with, and basically says that a log base b of x function is the inverse of the function y equals b to the x exponential. So a problem that you may get that you need to work with could be something like this. Log base 2 of the polynomial x squared plus 3x plus 3 equals 0. And you're trying to solve this equation. Well, I can think of the log as an equivalent exponential. So the base is 2, the exponent is 0, and that equals my log argument. At this point, I don't have a log to work with anymore. I have a polynomial that I know more about, and I'm able to solve by gathering everything to one side and factoring. This particular one would factor into x plus 2, x plus 1, and that would lead to the roots of negative 2 or negative 1, which I would check in the original log equation to make sure that they're valid. So that's the use of the inverse law. Okay, next, we're going to need a calculator for these. I'd like you to evaluate the values that are listed here under the power law, and once you've done that on your calculator, I'd also like you to predict an equivalent form of log 1 over 6, and pause, do that work, and then rejoin me. Okay, here's the first ones done. I've evaluated these on a calculator, and first up, log of 4 squared compared to 2 log 4. The decimal values are identical. Second line, log 5 cubed versus 3 log 5. The decimal values are equivalent. Now, notice that in the first case I have powers. I'm taking the log of powers. And in the second case, there's no exponent, only the base, and the exponent is now coefficient. It suggests a rule, and here's the rule. Log base a, whatever the base is, of the power x exponent n equals n times log base a of x. It's called the power law. Now, the third one can be written as a power if I think of it with a negative exponent. Now, using the power law rule then, that negative exponent becomes a coefficient in front of the log, so negative log 6 would be equivalent to log of 1 over 6. All right, I'd like you to now look at product law. Enter all these on your calculator. Find the decimal values, round them off to a few decimal places like before, and I'd like you to look for a pattern, and I'd like you to see if you can write down a generic law that doesn't assume any numbers. All right, you've rejoined me after doing all those. You should have found all of these were the equivalent decimal 1.3802 rounded off, and it leads to the rule that log base a of a certain value, x, plus log base a of a different value, y, is equal to log base a of their product. So 12 times 2 makes 24, 8 times 3 makes 24, 6 times 4 makes 24, and so they'd be equivalent to the log of 24. That would allow us to say things like log 200 equals the log of 100 plus the log of 2. And the log of 100 is the number 2. Log 2 is a funky decimal, so we'd need a calculator to get that as a decimal if we wanted to add to 2. All right, you do the quotient law now. Same idea as product law. Come up with some decimals and a pattern. All right, back again. Very similar to the previous rule, or called the product law. The quotient law works this way. First of all the decimal values are again the same. Notice that 18 divided by 6 makes 3. 9 divided by 3 makes 3. 6 divided by 2 makes 3, and so they'd be equal to log 3. And the general rule is at left. Log base a of a certain value minus log base a of a different value is log base a of their quotient. One more rule to go through. It's called the change of base law. Now, what I'd like you to do is two separate things. I'd like you to look at 2 exponent x equals 10, an equation. I'd like you to use the power law above and use it to solve for x. I'll get you started. Here's the beginning. You're going to write log of 2 exponent x equals log 10. Okay, so I maintain equality because I'm taking the log of both sides. Now use the power law on the left side and isolate x. After you've done that, I want you to use the inverse law and rewrite this equation to isolate for x and look for a pattern. It should lead us to the change of base law. Give that a try and then rejoin me. Okay, I'm going to show you the work on this one. There's my power law used. A power that I'm taking the log of can be rewritten with base left in place and the exponent as a coefficient. This is a multiplication, so to isolate x I would write log 10 over log 2, and I could evaluate that on a calculator if I wanted a decimal value. It would be log 10 divided by log 2, oops, and I need a bracket. I'm going to mess things up here. Let me put a bracket in there. There we go. Divide by log 2 bracket. And I get 3.322 approximately. So 3.322. All right. Now, using the inverse law, this is an exponential. I can write an exponential as an equivalent log. I would say log base 2 because the exponential base is 2. I would evaluate the argument 10, and it would equal the exponent x because logs give exponents. So this form is equivalent to this form. Now, x is the same in both of these places. So that leads me to this conclusion. Log base 2 of 10, if I have a base that's different than base 10, like base 2, it can be rewritten as log 10 divided by log 2, which I had over here on the left, which in this case, coincidentally, happens to be 3.322, which isn't so much the point that I'm trying to make. What this tells us is that if I take that, I'm just going to move this back a little bit, if I take that value of x and I put it in place of the exponent, I've found an approximation of the exponent on a base of 2 that's equal 10. So you may be asked a question such as, write 2 having, or write 10 having a base of 2. So that means find the exponent on a base of 2 so that it's equivalent to 10. Now we know that 2 cubed is 8. We know that 2 exponent 4 is 16. And 10 is between 8 and 16, so this is a reasonable value. Here's the change of base law. I'm going to call it COB, change of base law. Generically, if I have log base A of some value b, I can rewrite it as log b divided by log A, and I can use any log base I want as long as I use the same on top and bottom and it follows log base restrictions. Okay, so that allows me to say, for example, that log base 5 of 30 is equal to log 30 over log 5, which is now calculator ready because these are log base 10 values, where log base 5 is not on our calculator. I could, if I wanted to, write this as log base 2 of 30 divided by log base 2 of 5. I could, if I wanted to, write this as log base e of 30 over log base e of 5. You may remember that e is called Euler's number. E is approximately 2.718. It's irrational, and it's a number that's used for continuous growth and comes up quite often in exponentials. Now, log base e is actually more commonly written ln, and there's a button on your calculator for it, if you look for it, and it's read as lawn, like the green stuff in front of your house. All right, those are the 5 log laws, and they will get you through any different kind of log problem that can arise. If you keep those in mind, you can rewrite what you're given in a different form that's more convenient, that allows you to make some progress on the question. So review those, make sure you're familiar with the log laws, and then it's just a matter of applying them to situations.